Yes, students, as usual, live sessions we are conducting in order to have the better cognizance of the learning other than the recorded videos. So while going through those videos, while completing the assignments are what? The completion of notes. If you have any doubt, if you want more clarity, then be free to ask the questions. Yes, anybody can raise the question.
Sir, I have not understood the quantum numbers and the shells, subshells, and orbitals and electron spins. Please, can you explain it clearly once again?
Yes, certainly. Any other question? Any other body has?
Sir, I want explanation about radial shapes of orbitals.
Okay, good. Any other question? Means I want to know whether you are with questions or not. Now Shefali and Vaibhavi are with a question. Okay, Namrata clearly said she has with no question. Okay, other students who are with no question, please reply in the text box or say loudly no question. Yes, reply. Manthan, what's your reply?
No question, sir.
No, you need talk. No. Yes, Fayaz, reply.
नो क्वेश्चन सर पुढच्या लेक्चरला
Good. Suyash, reply.
No, sir.
Good. No problem. Be have a clarity. No problem. Mayuri said already. Yes, Shepali asked a question. Namrata, yes, Namrata said no question. Vaibhavi had asked a question. Tejas said no question. Okay, good. Now I start with the question of Vaibhavi. Sorry, Vaibhavi, your question will come next because radial distribution. No? First, you should understand quantum numbers. Then the radial and the angular distribution you will understand. So let us go stepwise. So let me discuss today only and only quantum numbers. Let you know the perfect clarity about the quantum numbers and application of the quantum numbers. Vaibhavi, are you getting this my point?
Yes, sir.
Yes, Jagruti, do you have any question about the learning? You can unmute and talk or message in the text box.
Sir, net is slow.
Okay, do you have any question now?
No, sir.
Okay. So students, shall I discuss the question asked by Shefali now? Her question is regarding quantum numbers. Please reply now. Now I am on the presentation screen, so I can't see your charts. Yes, students, shall I discuss the question asked by Shefali? That's the quantum
Yes,
numbers.
Yes, sir.
यस सर
Okay. See, it's a very interesting thing. Whatever chemicals are there, chemical compounds are there, or chemistry of element is there. Element, compound, anything you consider. Chemistry is there is because of electrons. Where are electrons in an atom? Those are at peripheral portion. We have studied the different models of the atom. At the center of the atom, there is a positive kernel, positive hard portion, heavy portion. I want answer from you. What we say for that hard portion, hard region in the atom, which is at the center?
Nucleus.
Yes, sir.
Yes, it is nucleus. What is the charge on this nucleus?
Positive charge, sir.
Right, and it is because of the protons. But only protons are not there in the nucleus. Neutrons also are there. And why protons and neutrons at the center? That we could able to answer if we know the Hensberg principle, uncertainty principle. And I discuss in the videos also. If still doubt remains, then it's also a very interesting concept. Proton can be outside, electron can be inside. But why electrons are outside and protons and neutrons are inside? That is answered by modern quantum approach, which was initiated by De Broglie in 1924. De Broglie has given us a concept of matter wave, which was a reality. But that concept we could understand with the help of mathematics. And Schrodinger, a great mathematician, has given us equation for that wave as like straight line or circle or ellipse or hyperbola. Different curves do remain. Geometrical entities are there. They remain with some function or equation. Likewise, matter wave. See, it's an interesting point. Matter wave is with also function, with also equation. And that equation, in order to describe the energy is a one of the status of that wave, is a one of the parameter of that wave. Schrodinger has put forwarded his equation. As soon as Schrodinger put forward the equation, people came to know three important basic parameters which affect the Schrodinger equation. I repeat, I'm talking about matter wave. I'm talking about description of the matter wave. Matter wave was initiated or proposed or described by de Broglie, and which was further described by mathematical way, a realistic way to understand that matter wave. By whom? Yes, please help me. Just I told you the answer. Who has described that mathematically?
Ernest Schrodinger.
Schrodinger.
Right, Schrodinger. And that Schrodinger's equation, if we solve, then we find there are three variables. With the help of those three variables, we can understand that wave. Which wave? Matter wave. Afterwards, people come to know one limitation of the Schrodinger. And after overcoming that limitation, one more variable is added there. So now there are four variables. Those four variables or those terms or those parameters to describe the matter wave. Then again question comes that matter wave is due to whom? Proton, neutron, and electron. Actually because of electron, because electron is the outermost portion, and that creates a wave, that creates a consciousness for the atom, and that consciousness of the atom helps to decide whether to react with the other atom or not. Means hydrogen, yes, hydrogen has how many electrons in its atom?
One electron, sir.
One.
One electron, and that one electron is one kind of wave, or you can consider aura on the hydrogen. Similarly, other electron on the other hydrogen, it also is one kind of wave. When those two waves come together, then they find, yes, we are made for each other. We can interact, we can mingle, and bond formation takes place. So bond formation, which is the vital aspect of chemical formation, is because of electrons, is because of matter wave. Students, are you understanding what I'm saying?
Yes, sir.
Yes, sir.
Yes, and that matter wave, as like we consider a person is with thoughts, other person, the thoughts are matching or those are not matching, those are different, those are opposite. If thoughts do match, then what happens? Interaction. Just wait, let me see who wants to enter. Sonika. The thoughts if are same, then the friendship occurs. Likewise, wave function, if they match, there will be the addition. If they doesn't match, there will be subtraction. So molecular orbital theory was dealing with the addition and subtraction. Before that came the valence bond theory. Before that came the wave function approach. And that wave, now if I have to talk about the only one, that's a wave on the one hydrogen atom, then that wave remains in one orbital, and that orbital is a three-dimensional representation, and that wave remains with the spin. That wave remains with magnetic quantum number. That wave remains with principal quantum number. So those are our four parameters which describe the Schrodinger equation, or Schrodinger equation gets the importance because of those four parameters. After solving that Schrodinger equation also, we will understand those four parameters. What are those four parameters? The first one is N. Second one is called L. Third one is called ML. And last one is called MS or simply S. And talking about small s. Now you might have studied that. What is the first one? N means?
Principal quantum number.
Yes, principal quantum number that we represent as capital K or capital L, capital M, capital N, and so on. It's a labeling of the principal quantum number, or we can represent it by, yes, numbers. Which numbers?
1, 2, 3, 4.
Right, 1, 2, 3, 4, and so on. Likewise, we represent the principal quantum number. It is a main parameter, and that decides orbit. That was a concept given by Bohr. Bohr was thinking about only orbit. He not thought about orbital. But orbit and orbital, we think same. No, orbit is just the energy level. And he was talking about that the principal shell or principal quantum number. And those we represent by the numbers 1, 2, 3, and so on. Just remember it now. Again, I am coming to the principal quantum number. Now, second quantum number, that's a orbital quantum number or azimuthal quantum number, which is a secondary to the principal quantum number. I want your help now. How do we represent that orbital quantum number? Which symbols?
SPDF.
Yes. That S is a small s or capital S?
Small s.
Right. Then P,
P.
then D,
D.
then
F.
F, then
So
actually could, yes, actually could be G, but only 118 elements are there, and for that we need not to go towards the G. Are you understanding what I'm saying?
yes, sir.
Yes. Now, again, I need your help. These are the letters, but we can represent these orbital quantum numbers or azimuthal quantum numbers by means of numbers. Which number we use? Do you know?
0, 1, 2, 3.
Right, it starts from 0. Means S orbital means 0. P orbital means 1. D orbital means 2. F orbital means 3. It is understanding and it is necessary in future calculations. Afterwards, we consider the numbers and with the help of that n plus L value in order to decide the energetics for that orbital that will help us. N plus L rule, that's a Boo principle. While studying that, these numbers will help you. So it is our orbital quantum number. Just the name of the quantum number and what are the possible representations for that quantum number that I discuss with you. Now, third quantum number is there. Yes. What is this ML? Third quantum number is
Magnetic quantum number.
magnetic quantum number. Yes. Now, magnetic quantum number takes values. Now, in terms of value, I'm talking from plus L to minus L. Means what? If I have to talk about, say, S orbital. S orbital means L is equal to what? 0. So, plus 0 to minus 0 gives many values S will take and all will be integers. Fraction will not be there. Now answer for my question. How many values are there between plus 0 to minus 0 or from plus 0 to minus 0? Between will be not the correct word. From plus 0 to minus 0, how many values are there? How
So
many
only
numbers are there?
1.
1. 1 is a number or number is 1?
Yeah.
Sorry. Means
one
what
value.
is that number? Value? No. What is that number actually?
0.
0 and total how many numbers are there? Only
1.
1.
0. Count is 1. Count of number is 1. But that number is 0. Am I confusing you or you're understanding?
No, sir. We can
Understanding.
understand.
Yeah, good. You're understanding. So there's only one quantum number that is 0. Okay. If I talk about the p orbital, p means what? What is the value of L for p?
1.
1. So it will take value from plus 1 to minus 1. Now help me. From plus 1 to minus 1, how many values are there?
3 values, sir.
Which are those?
Plus 1, 0, and minus 1.
Very good, very good, very good. Let us continue our discussion. The d orbital. What is the d orbital means? What is the value?
2.
L value 2. Means plus 2 to minus 2. How many values are there?
5
5.
values.
Which are those?
Plus 2, plus 1, 0, minus 1, and minus 2.
Brilliant, brilliant. Likewise, I hope you will understand f orbital takes the value from plus 3 to minus 3, which emphasizes there are 7 total values. Therefore, we say it is a reason why we say only one s orbital. P orbitals, how many remains? 3. Which 3? Px is a one orbital. Listen carefully. Orbital. Px is a one orbital. Py is a other orbital. Pz is a third orbital. All are of one level that we say as a sub-level. That sub-level is P. And P sub-level is further divided in the levels or the orbitals, and those are Px, Py, and Pz. Now, from this discussion, what you understood, how many d orbitals are there?
5.
5 d orbitals are there. Yes. Now, those 5 d orbitals, what are the names for those 5 d orbitals? One, dxy, other dyz, dxz, dx square minus y square, and dz square. As like px, py, and pz, these are the names for those orbitals. Which orbitals? 3 p orbitals. Then for d, how many orbitals are there? 5. What are the names for those 5 d orbitals that I have represented here? Means their orientation, how the lobes are there. Lobes means it is the electron possibility. Accordingly, we can find out the magnetic quantum number. Lobes, accordingly, names we can find out. dxy, dyj, dxz. We will understand that at later stage in detail. But at this moment, just if you understand 5 d orbitals are there, then it is what best. So generally what we say, d is a orbital. D is not the orbital. D is a sublevel. D is a subshell, and that subshell remains with the further minute parts, fractions, or dividing things. Those are orbitals. We say P as an orbital. Generally, in books also you will find those words. But true cognizance, true understanding I am informing today. P is not the orbital. P is a sublevel. P is a subshell. Sorry. Px is an orbital. Py is an orbital. Pz is an orbital. So this magnetic quantum number is specially for orbital information. Yes, up to 3 quantum numbers concept clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Now, 4th quantum number is a spin quantum number. It is said as an intrinsic quantum number. And that spin takes values. Yes. Which values are there? Spin takes values. Spin quantum number, ms or s. Which values does it take?
Plus half and minus half.
Right, plus half or minus half. I'm talking about one electron. It can take either plus half value or minus half value. And this 4th quantum number we come across because of improvement in Schrodinger equation. Who has suggested improvement? Dirac. Dirac suggested improvement in the Schrodinger equation. After solving the new Schrodinger equation, we could get 4 parameters, 4 variables, 4 important terms. Those terms are none other than quantum numbers. Now question you will be with, what is the use of these quantum numbers? As like you remain with the address, home address. So if any parcel or through post, if any letter is to come to your house, then what will you give? You will give, yes, help me. If you want, yes, right, help me.
Address.
Right, address. So what is the address of electron? We want to address that particular electron. We want to find that particular electron. We want to understand that particular electron. We want to label that particular electron. For that, we need to address. In college also, in order to address you, you remain with the class. Or suppose if division remains, division also, A division, B division, or batches also may be there. In that, maybe roll numbers will be there. Means all those things are there. Why? For in order to identify. In examination, you remain with the exam seat number. Why? For to identify you, to designate you, to know you, to understand you. Now our purpose is to understand electron, which is causing the matter wave. That's the electron wave. And to understand, to address that electron wave, to understand that electron, we found these 4 things are necessary. What are those 4 things? The first one, shell, called as principal quantum number. Second one, subshell, is called as azimuthal or orbital quantum number. Third one, magnetic quantum number, that decides orbitals. And 4th one is intrinsics. Further understanding about the electron means electrons intrinsic rotations, that as like the earth has the 2 kind of spins. So 2 kinds of rotations you can consider. One orbital rotation and other around its axis. That's we say the spin. So that spin rotation of the electron we are talking about. And for that, the 2 values are suggested. One may be the plus half and other is what? The minus half. Now generally we remain in the question. I continue discussion with this last quantum number. That's a spin quantum. Generally we say plus half spin. What's your understanding about the plus half spin? Rotation of electron in which direction?
Positive directions, a dextro rotary.
Okay, positive dextro and leo, that's optical activity concept. We're talking about the basic. It's not dextro and leo. For that positive negative is not here. Here I'm talking about. Here positive is for what? Dextro and leo rotations are for optical activity. That's a rotation of plane of polarization of light. Here we are talking about rotation of electron. Yes, please.
The positive means loss of electron.
And negative means?
Gain of electron.
No, no. It is about one electron only. We are addressing that electron. And to address, we are using this term positive and negative. Positive spin means what? Rotation by which direction? No, you are not understanding the question. Is my question clear? Yes, if yes, then say yes. If no, then say no. If I would repeat, then say accordingly.
No, sir.
Okay, my question is plus
Sir.
half is the representation for the spin. What is that plus half? Why per plus half? Yes.
Sir, Namrata has given the answer clockwise.
Yes, because I could not see the text message, no. So you have to say, Namrata, see, you have to talk. Otherwise, it's good. Whoever has said no, it's a good thing. Yes, it remains in the book. Plus half means clockwise spin. Minus half means anti-clockwise spin, which is not perfectly correct. But we carry that notion. Just I ask you one question. Consider electron is here. I'm considering electron here. And the electron is with one spin. Electron is spinning. Could able to see the spin of the electron? This is direction of spin. I repeat, this is a direction of spin of the electron. It is clockwise or anti-clockwise? I hope you know the clock.
Anti-clockwise.
Yes, this direction, because here 12 is there, here 9 is there. So from your point of view, here 3 is there and here 9 is there. So you will say the electron is moving from 3 to 12, means clock is moving from 3 to 12. Actually, it moves from 12 to 3, no? So therefore, answer is anti-clockwise. Now you are saying it is anti-clockwise. From your point of view, it is anti-clockwise. What should I say? From my point of view?
Clockwise.
Right, clockwise. So here difference is there. Only blindly saying that particular thing is there rotating clockwise or anti-clockwise is very unfair, especially for electron I'm talking. But if you see the fan, say ceiling fan or table fan, any fan you consider, do you know in which direction fan rotates? Generally, while seeing the fan, how will you see the fan? We will face the fan. Suppose ceiling fan is there, we will face the fan. Means we will see the fan. We will not see the fan from the rear side, no? Yes. What is the direction of rotation of the fan? Clockwise or anti-clockwise? Who knows?
Clockwise.
Clockwise. Okay, just you see the fan and you are rotating the, means you are seeing that fan. Rotation. Clockwise, anti-clockwise?
Anti-clockwise, sir.
Yes.
Anti-clockwise.
Anti-clockwise.
Right, anti-clockwise. Any fan you see there, you will find the rotation unless and until the that circuit gets inverted, no, it will rotate in the anti-clockwise direction. And the blades of the fans alignment in such a way that it will give the wind to us. If blades are reverted, then the wind will go. Means either spin is to reverse or the blades are to reverse. So the point of interest here is clockwise rotation means we say as a positive. It's a general notion which is not perfectly correct. I want to remove this notion, or I want to remove this myth from your mind, or what you think. Now let us see the mathematical point of view. If you consider the axis, just wait, let me draw the axis. Yes, could you able to see this line, fine line?
Yes,
sir.
sir.
Otherwise I make it, yes. I draw the other axis also. Yes, you can unmute the speaker if anywhere it's on, no, unmute that. Yes. One I'm considering as x-axis, say by means of the red color, and y-axis by means of the blue color. And in between that I consider one segment. Okay, both become the blue now. Okay. And that segment I'm starting it from the origin, and it is with the yellow green color. This segment I'm talking about. Now I made it dark blue. This segment makes angle. Now suppose if this angle is 45 degree or 40 degree, then angle made by segment is plus 40 degree or is a minus 40 degree.
Plus 40 degrees, sir.
I'm talking about this x-axis. Suppose if you measure x-axis. So how will you measure the angle? Just wait. Let me keep it for charging. See how we measure the angle? We measure the angle from x-axis to that segment, x-axis to that radial vector. Suppose I measure the angle from that segment to x-axis, direction is different. So generally we measure angle from x-axis to segment. Means if it's a first quadrant or anywhere, you will go in that way only. So this angle from x to the segment is what? The positive. And from segment to this x-axis, it is negative. Now tell me, which direction is clockwise and which is anti-clockwise? Now x to segment, this direction, clockwise, anti-clockwise?
Anti-clockwise, sir.
Anti-clockwise.
Right, anti-clockwise. And this segment to x, it is what the
Clockwise.
clockwise. Therefore, x-axis to segment is a positive angle and segment to x-axis negative, or other way. We say it is a first quadrant, positive direction of x, positive direction of y. Second quadrant, negative direction of x, positive direction of y. Third quadrant, x and y are negative. Fourth quadrant, x is positive, y is negative. These are all 4 quadrants. And while labeling those quadrants, also see how we are moving first to second. What is the direction? First, second, third, fourth. What is the direction? Clockwise, anti-clockwise?
Anti-clockwise.
Anti-clockwise.
Right means mathematically angle measured in anti-clockwise direction is positive. I'm talking about mathematics and quantum basics. Quantum works about mathematics, works with mathematics, go along with mathematics. Or mathematics is a base to understand that quantum chemistry or quantum aspects. So certainly positive means clockwise. That term is not itself proper. But from general point of view, that term came. Positive means it is the clockwise and negative means anti-clockwise in order to make some understanding. So it's a wrong understanding. But you have understood that thing in that way. Positive means clockwise. What is the purpose? A positive direction and negative direction, these are the 2 directions. Means clockwise and anti-clockwise. These are 2 directions. So one way and other way. And in true sense, what quantum says, if one electron is positive, other will be one electron. If you just spin one thing and other electron spin opposite thing, then if this positive, it will be negative. This positive, other will be negative. The relative approach. Relatively, those things are there. So with frame of reference, what you are talking, that matters. Then question arises, why only half? Why not 1? Because complete circle we can consider, no? But only plus half is considered or minus half is considered. Because from mathematics point of view, again I'm taking informing the advanced concept of the mathematics. Actually, it is a basic one, but people generally do not discuss that, therefore it become advanced. Students, are you with me now? Are you understanding what I'm saying?
Yes,
Yes,
sir.
sir.
Yes.
Yes, yes.
What is the advanced concept? Concept is if we were to measure any direction, then why only from one direction? Means if I'm talking about the spin of electron in this way, suppose if this way, from your point of view, it is clockwise. I repeat, from this way electron is moving. From your point of view, it is clockwise. And from my point of view, it is anti-clockwise. Are you following?
Yes, sir.
Yes. Then why only your point of view to be considered? Why not mine? Mathematics says equality necessary. Probability, find probability. So 50% probability of yours, 50%. 50% your decision, 50% my decision should be there. Means for the same observation, for the same rotation. Means what mathematics says, axis in and axis out. You be as origin. Means everybody should be considered as what? The origin. Means consider from your point of view. You are the origin. You are at 0, 0 coordinate. And x-axis is coming towards me. Means this direction is x out for you. But you are in x in. Means, see, this is x is direction towards me. But you are at x in position. I am at x out position. Are you understanding what I'm saying?
Yes,
Yes,
sir.
sir.
Yes. So from x in position, if I consider this rotation, then this rotation is clockwise. Yes, enough now. 0 to 180 means only first 2 quadrants. 50%. See your opinion. So what will you say for that? It is clockwise. Now what to do? Don't change the rotation. Don't change that observation. Only change the position. Means what to do? For remaining 50% region, you observe from my direction. Means you observe from x out direction. So that there will be justice. So that there will be equality. So from my direction, that rotation, if I continue that rotation from my direction, it is what the, yes, please help me. This direction from your point of view, it is anti-clockwise. Are you following this direction? Yes. I'm continuing that and you come to my place now and rotate that, continue. The same direction, same rotation, you will find it is clockwise. Clockwise, anti-clockwise. Yes, this direction from my point of view. I repeat, just pay attention now. I am rotating the electron rotating from 0 to 180. Now tell me, what is direction? Clockwise, anti-clockwise?
Clockwise.
From your point of view now, you are heading now, or x in, you are in clockwise. Yes. Now that measurement is over. 50% measurement is over. Half measurement is over. Now what you have to do? You have to come to my frame of reference. You have to come to my position. You have to come to x out position and see same rotation I am continuing. Now tell me, from my point of view, it is a clockwise, anti-clockwise.
Anti-clockwise.
Yes, means what I'm doing, I'm completing the same circle, but same circle from your reference point of view gives one result. Say it is a clockwise, the same observation, means same continuation from my point of view gives the other. So 50% your opinion, 50% my opinion. So same can be understood in different ways. So 50% only is considered, 50% part only is considered, only one portion only is considered, and therefore because of that 50% consideration there is half term, value is half, not one. Complete circle is we're not considering, only 50% measurement. And only one side if you have to consider, no, then say it is a, if one is plus half, say anything, who is correct and wrong, we are not doing, both are correct. Only what reference have changed, therefore the conclusions are different. You are also correct, I am also correct. So if from one point of view, but observation should be there from different electrons, should be from the same frame of reference. So if one says plus half, then other electron who pairs will be with the minus half spin. So pairing of the electron is what important. So who is plus half and who is minus half, it is not important. One is plus half and other is minus half, that is important. One is plus half, other is plus half, plus half, plus half, all have the similar spin, that important. Similarity in spin is there or opposition in the spin is there, that is important for the bonding point of view. And therefore don't get more indulged in this concept of plus and minus spin, positive spin and the negative spin. Think whether spins are same or spins are opposite. If opposite, then to one you will say plus half and to other you will say minus half. So in future when spectral properties you will study, then you will consider the only magnitude part. And therefore, students, for spin quantum number, which is intrinsic quantum number, we choose the two values plus half and minus half. I repeat, I am starting with the fourth quantum number, and actually time is near to the end. But firstly, I'm going to cover all. I'm talking about the fourth quantum number. That's a spin quantum number. It is an intrinsic quantum number about the electron spin. So if one spin we consider the plus half, other spin will be the minus half. Why plus half? Because mathematically, if we have to measure, then from one position, only 50% observation. From other position, rest 50% observation is to perform. So considering that 50% means what? 0.5. That number is plus half. Did you get more knowledge or not?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes. Now, our principal quantum number. Principal quantum number is a shell number, is a main orbit, means where the location exactly is. Okay, it is in Kudal Taluka. Means rough space is there, rough. Exactly where is it? Exact Kudal or Pinguri or Paushi or Dharap or which exact place is there? That is not clearly informed there. But the principal quantum number is a random place. Means is a ground floor or first floor or second floor about which principal quantum number talks. So principal quantum number says general level of the floor, general level. In the ground floor also there may be the cupboards, and cupboard also there may be the different positions. In first floor also similar cupboards may possible. Second floor also similar things are possible. So within that floor also different levels are there, no different heights are there. Means if you remain in one classroom, then the ground floor, there's a floor level and the bench level or desk level or the stage level or the board level, the levels remain different. The many sub levels are there. So principal quantum number talks about general level. It's just a floor concept. Ground floor, first floor, second floor. It's just the main energy concept, orbit concept, shell concept. It's called shell. Is that principal quantum number clear? Is the only floor number.
Yes, sir.
Within that floor, further energy levels are there. Within that floor, further positions are there. So if that's a main shell or shell we say, other will be sub shell. If there's a level, then that will be the sub level. And which are those levels? S level, P level, D level. And number point of view, 0 level. 0 level is one of the level in that main level, one level. But that's a second level, 2 level. That's a third level. So further levels are there in main levels. So that is called as sub level concept. So in ground floor also, first floor also, second floor also, such as sub levels may possible. That is an orbital quantum number. And that orbital quantum number only says S, P, D or F. That's the only significance of that orbital that's a azimuthal quantum number. Is it clear?
Yes, sir.
Yes.
Yes, sir.
Third is magnetic quantum number, which actually talks about the shape of the orbital. Shape of the orbital I'm saying. And the shape of the orbital, by the way, orientation also. And that is what the magnetic quantum number. So if +1 means px, 0 means py, and -1 means pz, it depends. Means what is the main axis. That's a principle. Again, the symmetry point also have to understand, then consider about the clear. So few consider +1 means Z. Few consider +1 means X. So there's no need to have that more ambiguity, keep the ambiguity about that. But timing, remember, because of the +1, 0 and -1, 3 values, there are the 3 P sublevels. Those are Px, Py and Pz. So this magnetic quantum number truly talks about the orbital. Is that third quantum number clear?
Yes, sir.
Yes. Fourth quantum number, the spin quantum number, the intrinsic quantum number, which talks about the spin of the electron, and half we considering because 50% from the only one position to be measured, and therefore plus or minus. If opposite is there, then in order to distinguish those opposition, one should be considered plus, other should be considered minus. And for that purpose, only plus and minus sign we are using. Don't consider energy absorbed, energy given, or electron added, electron come out, or dextro or leo. Don't get involved in those things. So it's a concept of quantum number. It's a basic concept which is necessary for electronic configuration. On the basis of this, we can write the electronic configuration. So Vaibhavi, had I answered your question?
Yes, sir.
Yes. Other students, the question asked by Vaibhavi and answer that I provided, is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Sir.
Yes, good. See, only simple, this concept I could have winded in the 5 minutes. It is possible. But here with different examples, with correlation, we are slowly understanding development of the chemistry. Yes, the way with which we are going, are you coping up? Are you understanding?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, student, then.
Sir.
Yes, it's a time near to end or it is completed. So I feel that we should stop for today's discussion. Tomorrow, I think my lecture is there. Tomorrow, let me continue. Tomorrow, I want further questions. If you remain with queries, I'm with answers. Let we discuss in deep. Let we understand the proper progress. Only memorization, there we will not stop. We will go for application. And if you could apply, then you will be the big boss in the chemistry. Application is important, but you should reach to that level, understand in that level. Yes. So students, shall we stop now?
Yes, sir.
Yes, sir.
Yes, okay. Other students, please reply. See, if question is asked, reply is important. At least reply in the
Yes,
chat box.
Yes, sir.
Yes, sir. Yes, sir.
Yes. So
Sir,
students, yes, Vaibhavi.
तुम्ही व्हॉट्सॲप ग्रुपवर समर रिसर्च फेलोशिप बद्दल एक पॅम्पलेट टाकलेलं त्याबद्दल माहिती हवी होती.
Yes, good question you asked. See, it is I also want that curiosity from the student. Information was given. It's a very fantastic opportunity. Those who complete Olympiad exam. Do you know Olympiad examination?
Oh, sir.
Yes, Olympiad examination means as like our cricket team or the volleyball team or say athletics team, nation team I'm talking about, they remain. Cricket is not in the Olympics as such, but I'm being considered any hockey team. Hockey team participate in the Olympics. So that team remains. Likewise, for different subjects, 6 subjects are there. Chemistry is one among them. The team remains. And those who represent the India, brilliant students do remain. Studious students do remain. What do? They study B.Sc as like you are doing. And where? At I.I.Sc, Indian Institute of Science, Bangalore. And then I.I.Sc is with one center called as IAS, Indian Academy for Science. And then IAS wants that talent from nation, maybe not completely found in the Olympiad, should be got for the research work. So they are searching you. They want you. They want your desire. Only desire they don't want. They want your work also. And those who are with meritists, those who are meritorious student, for them, merit means not only the 12th. They can consider by your work, your interest. Suppose you think that you are interested in the catalyst. Okay, you're interested in catalyst, but what you did for that? How many experiments you perform? If you actually work, then that shows your interest. At first year level, maybe not that much, but where you are involved, means your biodata they analyze, and from that they select the few candidates for what? To do research under guidance of eminent scientists throughout the nation. Means you have to choose. Okay, you want to work at TIFR, Tata Institute of Fundamental Research, under that scientist. Where in summer work means where vacations do remain. No, at that time you can work under them, so that a student will know what actually research happens. Purpose is that TIFR, BARC, IISc, IIT, or ICER, different institutions we say, but what exactly those are? Where, what exactly research occurs there? The student should know. For that purpose, they select the candidate and then you have to work. Means work in the sense what they will ask you to do these things, study these, do this titration, do this experiment. The guidance will be given to you. So you will get the chance to know the laboratories. You will get the chance to know the research work. That's the importance of that notification. So F.Y.B.Sc student can apply. Apply. Then it depends on your the merit and their decision. They will select. Sometimes by region point of view, they do auto select. Let from different regions the student be there. Not only for student, it is for teachers also. I also did an application one time. The from Bangalore one teacher was there. Dr. Pati was there. He was ready to guide. Miss we were, but the topic was different one. There is a research topic regarding quantum aspect only was there. So I know that as a teacher also I applied, and my students also applied before, but they were at FY. I remember Suren Nadkarni was there, and I think Mandar Kazarekar. These two students have applied. They were not selected, but they got a letter from their IAS. And they have sent one magazine. That's a Resonance one magazine, standard magazine. They have sent that. They have considered their involvement, their interest. So you apply. I suggest you to apply. Their recommendation prescription necessary. So take the prescription on such a teacher who is a doctorate. I am not a doctorate. So preferably you take from such teacher. If not, then I also will suggest your name. But your interest is important one. So you do apply so that in vacation period, you can work in eminent laboratories. Vaibhavi, are you getting this answer?
येस सर. पण अप्लाय करण्यासाठी म्हणजे कसं करायचं?
Just visit that website. In that it is there. A website is given there to apply. That form is given. So you see that form. That form remains. Electronic form is there. You apply. Read, go through that form. Visit that website clearly.
Okay.
Website address is given there. Yes, Vaibhavi, very good thing you did. Because of you, I could able to explain this thing for other students also. Yes, that's Neha. No, sorry. What? Shefali, Manthan, Sanika, Mahendra, Suyesh, Tanay, Shravani, and Mayuri. Are you getting this point? What I said?
Yes, sir.
To apply and
Yes,
keep
sir.
in mind, if you are studying, if you want to go for higher education, it's my ambition my students should go for the higher education standard institution. I want that you should study in ISC. I want that you should go in IIT. Yes, after BSc also you can go in IIT. I want that you should go in ICER, TIFR. But only want has no meaning. You have to work. It is a work. Only application, not a work. Okay, research is one factor. By the way, prepare for JAM examination, joint admission test examination. Okay, any more you want?
No, sir.
Yes, you work, and further if question comes, I am there with you. Yes, student, shall we stop now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
Yes,
thank
sir.
you for questions. You are very enthusiastic. Yes, when you remember the questions, I get a spirit to work. And when you remain with no question, I feel with whom I am talking. Are they interested to learn? If they are not interested, why should I trouble? Therefore, I also do not get the courage to, or the enthusiasm or the spirit to discuss. But a great thing, you are few but brilliant. Quality students, you are there. Good. Thank you for asking questions. Yes, shall we stop now? Again?
Yes.
Yes, okay then. Quit now. Today's session is over, lecture is over.